This is Unit 7, Lesson 3, Congruent and Similar Figures, Day 1. We're going to start out with some review from some of the material we learned from an earlier unit, so I'm going to go a little quickly through it. When we're naming figures, remember we name it by all the vertices in order. So if we had this quadrilateral, we could call it WXYZ, but we could also call it XWZY because we're going around the quadrilateral in order, starting with any vertex. When we name the sides of a figure, so when we're referring to the name of the side, we do that with the endpoints with a line segment over the top. So we could have AB with the line over the top to indicate the name of that side. Remember that BA and AB, they mean the same thing. They're interchangeable. They're both the name for that side. If we're talking about the length of the side, we indicate that by the endpoints only, no line over the top. So if we're talking about the number rather than the name, the number that it's the length, we just use AB with no line over the top, such as AB is 12 inches long. Similar and congruent shapes. Two figures are congruent if they're the exact same shape and the exact same size. All corresponding parts are equal in measure. Two figures are similar if they're the same exact shape, but they're different sizes. So, congruent figures. Two figures are congruent, then we know that the corresponding angles are equal in measure, and the corresponding sides are equal in measure as well. Excuse me. So here you can see all the corresponding parts are equal in measure. It's not as easy to tell sometimes when figures are not aligned in the same way, but you can see that there are corresponding sides here that are both 18 feet long, another 40-foot long segment, and you can see angle measures matching up as well. If two figures are similar, then the corresponding angles are equal in measure. You can see here the three sets of angles are all exactly the same, but the corresponding sides are proportional. That is, if we take two side lengths from each triangle and make a proportion, we can reduce it, and then if we do that with any other set of corresponding sides, we will get the same exact proportion every time. That's what we mean by the sides being proportional. Don't forget with your notation, ABC is congruent to DEF. That's the symbol with the equal sign and a little squiggle over the top. That means congruent, and it's important you put them in the right order so that angles that have the same measure that are corresponding are lined up in the same position in the notation. So A and D are equal in measure, B and E are equal in measure, C and F are corresponding and equal in measure. That way you can tell which angles are equal to one another without even having the figure, just because you know they line up in the same spot. If two figures are similar, then we write the notation with that little squiggle with no equal sign. Same deal about having the vertices that correspond lined up and aligned in the same position. All right, now we're going to get into some problems that are similar to what we did before and a little bit new. So here we're given two triangles, DEF is similar to triangle IGH. So first off, we're going to note the corresponding vertices. So D and I are corresponding, E and G are corresponding, and F and H are corresponding. And we know that rather than looking visually at the triangles, we're just looking at the way that the notation is written. So if that's the case, we know the angle measures are equal in measure. So if we're looking for all of the missing measures, we need to fill in all the angles. And you can see D and I correspond, so they have to be the same measure. So if I is 26, D is 26. And just like that, if E is 108, then G has to be 108. Now, neither F nor H have been shown, but we can do our computation to figure out that third angle measure and figure out that it's 46. So we can go ahead and fill in 46 for both of those as well. Now, the side lengths aren't going to be exactly the same because they are proportional. So that's something we've done before. We can make a proportion with the side lengths that we know. 12 and 21 are two of the lengths that are known from both triangles, small triangle to big triangle. So if we're solving for x, we can put the small triangle over the big triangle and solve for x and determine the length of x using a proportion. We can do the same thing for y, 12 over 21, and then we're going to create a proportion for y, making sure we put our variables corresponding to small triangle or big triangle, and do that computation and figure out the lengths of x and y. None of that side length stuff is new. We did that before, but the angle measure portions of these questions is something we haven't done before. All right, example 2. Now we're told that we have two parallelograms that are congruent. So it's important you look carefully at your notation to determine whether they're congruent or similar. Here they're congruent, and we're told some other information, and we're always going to label our figure with any information that we're given. So let's go ahead and do that together. ADC is 53 degrees. So we're going to show with our notation here that that is 53 degrees, making sure to put the little arc on our angle to show that it's the whole thing and not one of those small ones. BC is 18, so I'm going to write 18 along that side. KL is 24. EB is 15. So we've got everything labeled that we know. Now let's look and see what we're trying to figure out. We need to know LM. LM is a corresponding side to CB. So we know that's also 18. You can see since they're congruent, they're equal in measure, so we can go ahead and write in that they're 18. DC, let's see if we can figure out DC. Well, I'm not sure. We don't know the corresponding side to DC. Let's take a look and see what we have. We know that KL is 24, and corresponding to KL is AB, so we know that AB is 24. If AB is 24, since it's a parallelogram, the opposite side is congruent. Therefore, I know DC is 24. So we can go ahead and write in that DC is 24. LN. LN is a diagonal. So let's look. Do we know what the other diagonal is? Well, you don't, but we know that EB is 15. And since it's a parallelogram, we know that it's bisected by the other diagonal, so that we can say that ED is also 15. Well, if that's the case, since these are congruent, we know that the two halves of the diagonal on the other parallelogram are going to be also 15 and 15. Therefore, the entire diagonal is going to be 30. MO. MO is our other diagonal. We don't know anything about that one. Let's look back to the other parallelogram, and we can see AC. There's nothing labeled there. We don't know anything about it. Since it's a parallelogram, we don't have any way of knowing what that measure is, and so this is not enough information to fill that out. The measure of angle KNM, that corresponds to ADC, so I can fill that in as 53, therefore we can write that that's 53. And then angle LMN. Well, we don't know that directly, but we can use our information about a quadrilateral to add up all the angle measures. If N is 53, then L is 53. We can add those together, subtract from 360 and divide in half, and get that LMN is 127. If you're not sure about what I just did, please go back and re-watch the previous video. All right, example 3. Here we're given rectangle ABCD is similar to rectangle KLMN. Let's go ahead and label what we know. The measure of angle BEC is 32. KN is 4. AD is 6. KL is 12. And ED is 9.5. All right. We need to figure out DC. Well, I don't see anything with DC, so I'm going to look at its corresponding length of its other rectangle. And you can see it corresponds to NM. Well, it doesn't tell us what NM is, but we know that it's going to be 12 since it's the same length as its opposite side, since it's in a rectangle. So now, we still don't know DC, but let's call it X. Since these aren't congruent, they're similar, we know we're going to need to use a proportion to figure out the length that's missing. So we need to find two sides that are labeled in both rectangles, and you can see here AD and KN are both given. So we're going to make a proportion 4 over 6, And then we're going to put the corresponding sides from the small rectangle and the big rectangle along with that and solve our proportion like we know how to do. And we come up with x is 18, therefore DC is 18. LM, you can see, is the side opposite to KN, so we know that's 4, so that one is a little bit more straightforward. LN is the diagonal. We don't have any information about that diagonal, but we do in our larger rectangle. We know that the length of ED is 9.5. So I can use the same situation and solve a proportion. So I'm going to call NO Y because it's a new variable and I need to figure that out. And then I'm going to do the same thing. I'm going to use my proportion 4/6 and I'm going to use Y and 9.5. And then I'm going to solve that and come up with the Y is 6.3. Therefore, NO is 6.3. If we're looking for the entire diagonal, we know that it's going to be double because a rectangle has its diagonals bisecting each other. Therefore, 12.6 is the length of the entire diagonal. The measure of angle LOM is corresponding to BEC. Therefore, that is 32. All right, that's it. I'll see you tomorrow.